Okay, let me give you another example of limits. So here, suppose you have a function f of x equals 2 to the power of x here. You can say that the limit as x tends to minus infinity of this function here is, so as you head towards minus infinity, then you're going to head towards 0 here. And then as you head towards positive infinity, you're going to head towards infinity up here. Okay, so when you look at this, if you think about it, as you increase x, what you're actually doing is, well, 2 to the power of x. Suppose x is, let's say, 4. It means 2 times 2 times 2 times 2. So you can see this number gets bigger and bigger each time. So it will head towards um, towards towards infinity. Now, if you look on the negative side, as you head towards negative infinity, let's say minus 4 here, then you will have to imagine this as 1 over 2 to the power of 4. So from our section on indices, we don't really understand what it means to have a power of a negative number. So we would jump to something like this: 1 over 2 to the power of 4. You see, as this number here increases, let's say 1 over 2 to the power of 999, this number here is going to get really, really big, making the overall thing very, very small. Well, anyway, the limit here as x tends, well, the limit here will be 0, the limit here will be infinity. Okay, and then if you look at this function here, where this thing here is 0.7. You see, whenever you have 0.7 times 0.7 times 0.7, because 0.7, it's every time you times it by itself, it gets smaller and smaller and smaller. So as x heads towards infinity, the limit will be 0. And then on this side here, if you look at this here, 0, well, here, the limit as x tends to negative infinity will head towards positive infinity. Okay, so now the question is this: how would you go about finding out the limit of this? You see, you can't use that same argument because you you see, as x gets really, really big, this whole thing here is very big. And then, but then as x tends to infinity here, this whole thing here will also be very big. So you've got you can't really determine anything. You see, the earlier, if you have something like this over, let's say, 5 to the power of x. Okay, let's change this to, let's say, 2 to the power of x. You see, as x tends to infinity here, you can use the argument, this as x tends to infinity, this whole thing here will be very big. Well, if you have something, if you have 5 over something very big, then the overall thing here will be very small. But you can't use that argument with this here, because you've got something very big divided by something very. You can't use the same argument. So to do this here, well, it's just a trick. And now it doesn't matter if you don't understand it. Just watch it and just carry on watching the other videos. It doesn't matter if you don't understand it, because there are things that I haven't taught you yet. But let's just watch it anyway. So you start out with this here. You're trying to find out the limit of this as x tends towards positive infinity, meaning as x gets bigger and bigger, like 999 in here, 3 to the power of 999, or 5 to the power of 999 here. Well, anyway, rewrite this as this. So remember, whenever you have whenever you have let's say 5 to the power of a times times 5 to the power of b, you can actually write 5. Well, all this is done in in the section on indices. So if you don't understand this, then watch. Well, anyway, from here you can jump to here. Okay, and then this bit here you can jump to here. Okay, so here this is 5 to the power of 1. My point here is that if you're given this 5 to the power of x times 5 to the power of 1, you can just add these two together. So it's 5 to the power of x plus 1. Well, anyway, so from here from here you will get to here, and then and then well, just most 3 squared is 9. So now break up these two fractions, okay? Because if I were to give you a over b times c over d, you would just get top times top, bottom times bottom. So here break these two fractions apart, okay? So that will give you this here. So here I'm just breaking up the two fractions. So now, okay, here's the thing. The limit of this thing here, you see, this thing here changes as x changes. This number does not change. But here's the thing. I haven't taught you this, but whenever you have a number that doesn't change, you can actually take it out here and put it in front and just concentrate on this bit here. Now, it doesn't matter if you don't understand this bit. Just watch it through, okay? So now, well, this thing here doesn't change, so I can actually take this outside here. So now I've got this times the limit of this, whatever this limit is. Okay. Now, when you're here, from the section on indices, if I were to give you 3 over 5 times 3 over 5 times 3 over 5, top times top times top, bottom times bottom times bottom. My point is that you can get from here to here. Okay, this is actually the same thing. This bit here is exactly the same as this here, because if you were to do this here, 3 to the power 3 over 5 times 3 over 5 times 3 over 5, that these two are actually the same. If you don't understand this bit, watch the section on indices. So this bit here is exactly the same as this bit here. Okay. Now here's the thing. Oh, where did it go? Okay, sorry. Here's the thing. So this bit here is exactly the same as this bit here. Here's the thing. Whenever you have this number to be smaller than 1, then you're gonna get exponential decay like this. It's just like me giving you this. Whenever you get this times by itself, because this number here is smaller than 1, it's gonna get smaller and smaller and smaller. If this number here is bigger than 1, let's say 1.1, then whenever you times 1.1, it's going to get bigger and bigger and bigger. Times 1.1 again, it's going to get bigger and bigger. Because this number here is smaller than, well, because 3 over 5 is smaller than 1, every time you times it by itself, it's going to get smaller and smaller. So we can say that this thing here will head towards 0. Now this whole thing here equals 0. Then when you get 0 times this thing here, it will be 0. So you can actually say this whole thing here equals 0. So the limit as x tends to positive infinity will actually be 0. So after all that, the limit will be 0. Okay.